Describe what I have up here on the board.
Pictures of apples.
And what would you say? If I said, what do I have up here? You would tell me I have...
Apples. That are different.
They look the same to me.
They're red apples.
They are red apples. What else?
They're similar.
They're similar. The shapes are about the same?
There are 4 apples up there.
There's 4 apples. So you're telling me I have 4 apples up here.
There isn't one.
So if I said, how many apples are up here? Would you say I have 3 apples, 1 apple? Or would you say you have 4 apples? Because we see things that are together and put them together. We're going to end up doing the same thing today. Again, not with apples, not with pencils, but with numbers. So if you could, please take out your notes and write. We already copied this down, but you have to remember what coefficients and variables are to really be able to group numbers together. For things to be alike, they have to have the same variable, and also it has to be raised to the same power. So for terms to really be alike, for it to be 3 apples and 1 apple, so you can say that you have 4 apples, you have to have the same variable, the a, the b, the c, x, y, or z, whatever it is, and also has to be raised to the same power. Please write that down. Some examples of like terms. So x and 2x would be alike. W and w over 7. 5 and 8 would be alike. However, 5x squared and 2x squared would not be alike. Why do you think that these two are like 3x and 2x, but 5x squared and 2x are not alike? What's the difference between the two?
One is to the second power, and the other one to the...
Good, they both have the same variable, but this one's raised to the second power, so it's not really the same. You can't put them together. They don't match up. It's like having apples and bananas. 6a and b, again, it's like having apples and bananas. If you had 6 apples and 6 apples, you would say, I have 12 apples. But if you have 6 apples and 6 bananas, would you say I have 12 apple bananas?
Yeah.
Is there any apple bananas? No, so you can't put them together. So if you're describing it as apples and bananas, you'd have to keep it separate. You can't put those together. They're not alike. Why are 5 and 8 alike? Why could I put those together?
There's no power or base.
Good. What's the variable in 5? Nothing. What's the variable in 8? Do nothing and nothing match? Yep, you can add 5 and 8 together. They would match. They go together. Yes?
That's why we can add like 27 and 542.
Yep. But could you add 3 apples and 572?
No.
No, they don't go together. They're different.
Wait, so if something has a label, you can add together?
So let's add the same label. That's a good point. You got to think of these variables almost as labels. So if it's the same label, the same variable, the same power, and it's the same label, you can put them together. They're like things. But if it's slightly different, you can't.
What about if you had $3.10?
But it's still the same money. You can have money together because it's the same thing.
Oh,
Okay? There you go. The copy offer. If you guys could please write this down. We're going to move some like terms to the top left corner. Some things that go together. Please come up and move some stuff around for me.
Is the 2 divided by 3 with the a or not?
Yes, ma'am.
Or just continuing.
Ooh!
What else goes together? In the top right corner, put something else that goes together. Yes, that goes with it. That goes with 2/3. How's she doing?
Good.
How about x squared? Does that go anywhere? Question. So does the x squared go y squared?
No, because it's y squared.
Nope, because it's different. How about the z? Any z's up there?
No.
Any k's?
No.
How about t over 2?
No. Well, there's one here, but there's a.
But you just care about the variable. What variable is the t? It's t. What power? So it will go. Give her a round of applause. And you guys all have a fancy paper where you can move stuff around. So what can we do to signify that these y's go together or these a's?
I just, circle one, put a square around the other.
Good. So you might want to circle one. Put a square around the other.
And the other one.
And then maybe underline or a
Triangle!
pyramid.
My favorite shape.
So that shows what goes together. So this is circle, they go together. That's pyramid, they go together. That's got what sort of looks like squares, so they go together. So any questions on this? Does it make sense so far? So at times you're just going to say identify like terms. So all you would need would be circles and pyramids and underlines and squares and rectangles and lines and bears of mine. But other times you might actually have to, if this thing works, combine them. So in this example, if you had 4 x's and 5 x's, and I said, how many x's did you have? Would you say, oh, I have 4 and 5? What would you say? So you would actually take them and put them all together and say, I have 9 x's. And the book at this time, or the test or the worksheet, won't just say identify, it will say combine like terms. It could also say simplify. And down here, what goes together down here? Sorry? So the x's. What else? The y's go with it? No, so they'd have to kind of be by themselves. So how would we say this? So this would turn into 5x plus 2y. You're not going to get nice easy answers like 24 or 18 as an answer. You're going to get weird stuff like 5x plus 2y. And you can't push it together any more than that because they're not alike. So you just have to leave it like that. Any questions? So far so good?
Are they like divisible?